What's up, guys? This is Dr. M with M Knows Chem, and I'm here to talk to you guys today about electron configurations. So there's a lot of theory that goes along with why different energy levels come first, second, third. I'm not going to worry you guys with that. What I want to focus on today is how do you get the answers right on the homework, on the quiz, and on the test. So let's just dive right into it. There are two different ways that I know of to figure out the electron configuration. And the first way I would say is the way that you learn in class. It's the way that your teacher might start off talking to you about. And there's lots of little circles and boxes and things like that and arrows. So it looks really confusing, but I learned a second way how to do it, and it makes the first way a lot easier to remember. So let's just talk about the things that you have to know before you even start. So the first thing is you have to know the number of electrons that go within each orbital. I want to talk about the hard way first. And by hard way, I really just mean the more classical way that is normally used to being taught. So I just kind of want you guys to listen first and then try to make sense of it. So in the way that you may have seen your teacher, your professor drawing circles with the orbitals and energy levels, and you're like, what is that? So I'm going to tell you how to build this circle. There's a bunch of circles with arrows in it, so I'll tell you kind of how to build that. So first thing I'll say, the first row has 1, the second row has 2, third row has 3, fourth row has 4. If you can remember that, you'll be able to set up your table and follow it as many times as you want. You'll never get it wrong. So let's jump in. So what do I mean when I say the first row has 1? This is the order that you will put your orbitals in. 1, 2, 3, 4. So when I say the first row has 1, I'm going to put a 1s, and I'll put a circle around it. That's my first row. My second row has 2. That means I'm going to take an S and a P. So I have 2S, 2P. I'm going to circle both of those. Now let's go to the third row. Third row has 3. I have S, P, and D in this one. So we're in the third row. 3S, 3P, 3D. Just for good measure, I'm going to do the fourth row because some of your professors might be crazy. So I want to expose you to that. So fourth row, well, actually let me circle these. And my last one I'm going to have to kind of squeeze over here because I started a little too far to the side. But it doesn't matter. So 4S, 4P, 4D, and over here I'll kind of write 4F. I actually won't even get there, so it really doesn't matter. But in your paper, if you ever have to do F, just make sure you leave enough space to fill out the whole thing. The main thing to remember, you gotta have a diagonal over here. If you don't have a diagonal, you have not set up your table right. Okay? So okay, let's jump into it. Now you draw your arrows. Your arrows will tell you the direction that you follow. So the first one, everything's going to go diagonal. So the first one, you just go straight through the 1S, you don't hit anything else. The second one, you go through the 2S and you don't hit anything else. But the third one, if we're going diagonal, we hit the 2P and the 3S. So we just kind of keep on going it that way. And I'll stop there because you'll realize that we've actually covered a large part of the periodic table here. So let's just go. So when you are setting up your electron configuration, you're going to need this, but you're also going to need to know how to set up each individual piece. Each individual piece will have this box, or this circle, excuse me, here, and then you'll put the number of electrons that you can fit inside of this orbital. So that means you're going to need to know how many electrons can fit within each orbital. So let's say we are going to, and I'll pull out my handy dandy periodic table. There's usually a periodic table around. So let's say we're going to go to fluorine. Fluorine is atomic number 9. There you go. So fluorine is atomic number 9. it has 9 electrons. I'm going to write that down. That's going to be important. We have to account for each electron. So what we end up doing is we start off with the top arrow and then we go down. So if we're doing fluorine, I'll go here. So we start off and we take this circle and we write it down here. So we got 1s, and because we have not reached 9 electrons after we fill this up, after I put this 2 here, we still have 7 more electrons to account for. So that means we got to keep going to the next arrow. So the next arrow, we take our 2s and we fill it up with the maximum. So s has a maximum of 2, so this one also gets 2. I've gone through the 1s, I've gone through the 2s. Now we're going through this third arrow, so we hit the 2p. The p can hold a maximum of 6 electrons. So we take the circle for the p, 2p. I'm going to take this 9 and kind of put this away because I'm running out of space. Now, I'll put that down here. So now we have to look and see the remaining number of electrons. So we've already accounted for 4. P can hold a maximum of 6, but we're not going to use 6. If we use 6, that means we have 10 electrons, and that's too many. So what we do is put 5 here. If we add up the electrons that we've used to fill up these orbitals, it must equal the number of electrons of the element we're talking about. If you have gone through your electron configuration and you add up these superscripts here and they do not equal the number of electrons that is in your atom, you've done it wrong. You need to start over. In my second example, using the hard method, I'm going to do one that's a little bit further down the periodic table. I'm going to choose iron. It has the atomic number of 26, so that's 26 electrons that we have to account for. So I've started off writing my, setting it up here, but we still have to follow the method that has been already set up. So let's jump in. 1s, I put that here. And we end up filling it up, so 1s2. Now we keep going, 2s, I'll put that here. Let me put that here. And another 2 here, because we still haven't reached 26. We've already done 2s2, now we go to 2p, 2p6, that's a 6. Then we keep going to 3s, yeah, 3s2. Now we keep going, we're on the 4th arrow here, so 3p. We keep going, 4s, which has a 2. Now we're in the 1, 2, 3, 4, 5th arrow going down, and we hit 3d. Now we just have to make sure that this is the last orbital that we'll have to kind of talk about here, because we're really close to 26. What you really have to do now is just figure out how close to how far away really from 26 you are. So really, we're only going to put 6 electrons in this d orbital, and now we're finished. If we count up 2 and 2 and 6 and 2, 6, 2 and 6, we'll get 26 electrons. That's how we know that this is the correct electron configuration for iron. Now that we have that, I want to talk to you guys today about the easy way. Let's just do it. In the easy way, you can look at your periodic table, and as long as you can locate where your atom is that you're trying to find the electron configuration for, you'll be able to read it like a book. And it will blow your mind. So let's go. So instead of kind of holding up my book, I'm going to draw kind of a mock periodic table here. So I'll be able to give you the rules. So all right. This is kind of a piecemeal version of your periodic table. Actually, it's more like that, and I'll show you. So First thing you have to know is there are specific locations where different orbitals are kind of located. This section over here in the column that's on your left-hand side of the periodic table, that's for S. This block over here, that's for P. The D block is right in the middle. And then F is on the bottom. You actually won't get to F that often, but let's do it. So there are a couple of rules. The first rule is that this one is helium, right here. Helium is placed over in the P block because it shares similar properties to all the rest of the noble gases underneath here. But in all other purposes, you have to pretend that your helium is here. Helium really belongs in the S block. So that's going to be our first rule. Helium is in S block. The second thing that you'll have to know is you read this like a book. So left to right. Then top to bottom. I will say this the American way a little bit, but left to right, top to bottom. And when I say that, what I really mean is, let's say you're doing the electron configuration of hydrogen, which is the first one. You start off here, that's 1s1. If you go over to helium, which is really technically here, that's 1s2. How did I do that? The setup for this is really row first, then orbital, then number of electrons. So if you can remember this, if you remember the way to set up each of the pieces, you will always get it right. So what row are you in? What orbital block are you in? And how many electrons within that row? So let's do it. So the first example that I gave was fluorine, still atomic number 9. Fluorine is about here. Yeah, so it's about here. Now if you look on your periodic table, here we go. Fluorine is here. If we read it like a book, we can still follow this method. So row, orbital, number of electrons. So first row, 1s1. First row, s orbital, 1s2. Excuse me, I said that wrong. So the first row, 1s2. First row, s orbital, it's got 2 electrons. We still can only give the number of electrons that it can have is still going to be the maximum for each of the particular orbitals. So you still have to remember that. So 1s1. If we're going down here, if we're going down here, we need to get to the second row. But this is over here in the P block. We still need to cross over the s orbital to get over into the P block. So we've already got, so let's do fluorine. Here we go. 1s2, because we've already done our first row. Helium we pretended is over there, so there's nothing else on this first row that's in the P. So 1s2. Now we go to our second row. 2s. And then now that we're leaving the now that we're leaving the s orbital, we have filled it up. So there's 2 maximum number of electrons here. 2s2. After we're finished with the second row in the S, we still have to go straight across over here to the second row, but in the P. So the last one, 2, because we're in the second row, P, because we're in the P orbital, and we have to figure out the number of electrons that are in the P orbital. A quick and easy way that's going to blow your mind as to how to figure this out. Each atom has 1 more electron than the last. So boron has 1, carbon has 2, nitrogen has 3, oxygen has 4, and fluorine here has 5. So this last piece, we're going to give 5 electrons to this P orbital. So 2p, 5. That was relatively simple, right? let's do one that's a little harder. That's actually not iron because I did iron before. So we will still need to know the setup here of rho, orbital, and the number of electrons. But let's go to chlorine. Why not? Chlorine is atomic number 17. It is in the third row, but it's in the P block right here. So let's build it. And I want you to follow along. Look at your periodic table as you are listening to me talk. This is pretty important. Okay, so we're trying to get to chlorine, number 17, over here. So what do we got to do? 1s2, because we're pretending this helium is really over here. So 1s2, there's nothing over here. So now in the second row, actually I'll write this out. 1s2. Now we got to go into the second row. 2s, and since pretty much every time we have to lift our finger up to go to the next row, that means we're switching out from one orbital to the next. Every time you have to lift your finger up, you need to say how many electrons you put inside that orbital. So okay, 2s2, 2s2. So that's here. Now we go straight across. 2, because we're still in the second row. 2, but now we're in the P block. 2p. And in this example, chlorine is down here, so we have to fill the rest of this up. So 2p6. Now that we got our 2p6 here, we're done with the second row, but now we have to go to the third row. Now we got to go to the third row. So in the third row, this is where sodium is. So 3s, because we're still in this S block. We're still in this S block over here. So 3s, and then since we're filling it up, chlorine is over here. We're filling it up, so it gets a 2. 3. So now we still got to go across, and we're still in the third row. So 3, but we moved over to the P block. This one is the P block. So P, and then now every time we lift up our finger, it's another added electron. So here's chlorine here. So we do 1, 2, 3, 4, 5. Chlorine has 5 electrons within the P orbital. So 2p5. That's our electron configuration for chlorine. There you go. Using this method is a way to be able to, it will give you hints as to how many electrons are within each orbital. Because if you stick within the same row, let's say we're looking at this third row with the sodium and the magnesium. The s orbital has 1, 2 maximum electrons, and that's right? For p, if we have to start in the place where the p orbital cuts, but if we're looking at the p orbital, the p has a maximum 1, 2, 3, 4, 5, 6 electrons. So with the d, as long as you are, sectioning it off right, the d orbital has a maximum of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's the border. So it has a maximum of 10 electrons. Oh, there it is, 10. Now, let's say you forgot the number of electrons that are maximum in F, because actually it's kind of easy to forget that one because you really don't use that one that often. All you got to do is, stick with one row, but go from the left to the right and count how many are there. Spoiler alert, it's 14. Spoiler alert, it's 14. So this will also be able to give you some hints as to where, how many electrons can be found within the different orbitals. There is one notable exception though. One thing that I have to make sure that I say about if you're going to use this method, you just got to know, okay? The D block. The D block starts where the S is at the fourth row. That looks terrible. The D block starts where it looks as though it's in the D block looks like it's going to be in the fourth row. It's really the third. This is what you're going to have to remember, and that's the thing. I usually draw an arrow here in my periodic table that pretty much just says anytime you cross from the S into the D, you need to take your row number down one. So what does that mean when I say that? When I say that, let's say we're looking at chromium, because it's in the first row of the D. In the S orbital, this is the fourth row. So you'd be very tempted to, say 4s2 and then 4d, 1, 2, 3, 4. But it's not 4. Once you cross from the S into the D, you gotta scale it down one. So we go 4s2, 3d4. This is gonna happen for all of these rows though. So let's say we're in the 7th S row, we go 7s2, then 6d, however many electrons, okay? So that's gonna be really our third and final rule. And I don't really have that much space here, so I'm actually just gonna leave that there. But third and final rule is the D block is gonna be shifted down one row. You're gonna just have to pretend and know that D is in one row lower than it actually is, technically higher. But when you cross from the S to the D, if you have, let's say 4s2, then 4d anything, no. You gotta start with 3d. It does not start with 4d. So at the risk of making this video extremely long, I'm gonna stop here, but using these two methods, these are the ways that are, I would say, most common to learn. The first way is, I would say, the most common, just because that's the classical way that, teachers and professors are used to teaching. Once I learned this, I stopped even trying to remember how to set up the circle charts, but for some it makes a lot of sense. So that's why I wanted to show you both. So if you can remember these, if you remember the three rules, that helium is over in the S block, it's not really in the D, and you read this like a book, left to right, top to bottom. And then the third rule, I didn't write here, but the third rule is that the D block is shifted down one. You will always get this right. You will always get it right. So really, you guys didn't really need to know all the theory behind why certain rows have a different energy level. So especially going from the S to the D, there's a lot of chemistry that goes on between that in terms of energy levels. Y'all don't want to know that. You just want to know how to get the answer right on the test. So there you go. Did this lesson go a little fast? Would you like some more personal instruction? I am available for private tutoring. I also do some Skype tutoring. So you can send me an email or go to my website, www.mknowschem.com. That's emknowschem.com. Or you can hit up my other website, ShawneeSamuelPhD.com. I'll put some links afterwards. You can also send me email. I'm always generally available. I also want to say thank you to all of my new tutees. I have been very busy, so that's one of the reasons why I haven't been able to upload a new video, but I've been tutoring a lot, so the need for chemistry is out there. So if you feel as though you're just not quite catching it as quick as you can in class, I mean, it's really frustrating when you're in class and everyone else is raising their hands after the teacher asks a question and you're just like, oops, I don't know anything. That's a real downer, okay? Call me. I'm available for private tutoring. I do some Skype tutoring. I'm also on Wyzant, so they have an online platform as well. So don't struggle. Don't struggle alone, at least. Once you get the grade, once you're out of the class, you may not necessarily want to be a chemist for the rest of your life, but if you need chemistry to get to where you need to go, do what you need to do in order to pass. Call me.